Hi, this is Muresh with New Power Energy Systems. Solar is widely available, plentiful, and predictable. However, despite recent advancements, tapping this solar energy and converting it to usable electricity remains a challenge. Solar thermal claims lifetime costs, lowest lifetime cost, but it requires a very large scale and it also requires a lot of water, which may not always available in areas such as deserts where it's best suited for. Thin film requires too much land. Solar PV, regular PV, it's reducing in cost and it's increasing in efficiency, but there are limitations to both. We are using satellite solar cells, known as tri-junction cells, which are more than 40% efficient. In order to save cost, what we do is we take a lens and concentrate light onto the cell. And the lens being cheaper, it allows us to save cost. And this is known as concentrated PV. Others do it too. But we do it in a manner that allows us to save 40% costs. Also, we can pack our modules better, which allows us to achieve 1 megawatt in 3 acres or less. No other technology can do that. Thermal requires 5 to 6 acres per megawatt. Typical concentrated PV requires 5 acres per megawatt. Regular PV requires 4 acres without tracking. Thin film requires 8 to 10 acres. And we are able to do even tracking and support at $2 per peak watt DC in 3 acres per megawatt. This is existing technology. We have a prototype. The way we do it is, if you look, we use the same cell and lens that everybody else uses. But the cell and the lens actually comprise only less than 20% of the cost. The rest is taken up by support, tracking, and heat dissipation. If you look at the structure of our competitors, you see these are huge structures which require a lot of metal, a lot of concrete, and you see their large size. Look at the relative size of the man with respect to the panel. Their movement is like this. For the first degree of freedom, it moves like this. For the second degree of freedom, it moves like this. This puts all the weight onto this base pole and it requires heavy hydraulics. Whereas our system has one fixed pole over here and a wheel set over here. So it moves in this fashion for the first degree of freedom, and second degree of freedom it moves like this. The weight is distributed across the system so that we can use simple car wiper motors. Also, we have innovative heat sink which allows to achieve far lower operating temperatures, which lead to better performance in terms of electricity produced and also the lifetime performance of the cell. And this is all proven technology. We have a prototype, we have 3 provisional patents, we have backing from industry leaders such as Mark Thomas, who is the president of Ditech Solar, Bruce Riven, who is the principal at Technology Venture Consulting, Jasun Pangaru, president at Alt Energy Canada, Mona Chopra, TI charter member and vice president Bank of America. We have established collaborations with our suppliers and also potential vendors in terms of manufacturing. We have also letter of intent to buy from our prospective customers. We are looking for 400,000 US dollars to convert this technology from a prototype to a manufacture worthy phase. India, through its solar mission, aims to achieve 1 gigawatt by 2012 and 20 gigawatt by 2022. US is also going to be a major market, which will be around 5 gigawatt by 2014. And it will be the largest solar market by around 2020. We expect to tap only a small portion of this, less than 2%, and break even by 2014. And will be able to achieve revenues of around $500 million by 2017. Any questions? Please feel free to ask.